is about to blow up. Flame and debris is coming down. BBC announcing. And of course they apologized for it. I'm thankful for that. But they announced 20 minutes prior that the building had collapsed. But there it is. They apologized for this mistake. How could you even make this mistake? It's not possible to make this mistake. So do we have evidence of a controlled demolition? Do we have evidence of chemical reactions? Do we have evidence of extremely high heat sources? Well, who's inside? Oh, the CIA, the Secret Service, the IRS, Department of Defense, Mayor Giuliani's office, Securities Exchange Commission. Could Al-Qaeda have gained access to get in there and do all this work required to get this extremely strong building to fall at near free fall speed? If Building 7 was a controlled demolition, and since the necessary resources and months of planning and execution and planning of explosives requires a conspiracy, and the building was demolished on 9/11, then it is a reasonable assumption that WTC-7 must have been a part of the overall conspiracy of 9/11. And since we've already shown that Al-Qaeda didn't have access to this highly secure building, the conspirators must have been someone who did have such access. Now, this is from NIST, and it's showing these detached columns. Floors breaking through the steel decking, 22-gauge steel decking the bottom, breaking through the girders, holding the floors up, freeing up and then falling. This is the best I have received so far in terms of, oh yeah, these are the plans, these are the blueprints, here you go. No, this won't help. This is nice, shows me where the floor beams are, the girders, shows me where the column locations are, shows me this magic column 79 right there, but I need the plans and specifications to properly model this building in CAD and run what I want to introduce you to. Everyone should know what finite element analysis is. Is it, using Cicero, a sword of Damocles? Maybe. Finite element analysis has been around in the 40s, partially to help us better understand structures and how to design and develop better structures. How to know to use, you can use less material here, you need to use more material here, different material there. These are pictures of finite element analysis method stills, computer-generated images. It was developed 70 years ago, and it involves taking a solid created in a computer CAD, parametric usually, 3D, and then applying a mesh, increasing the resolution of the mesh, making the nodes smaller and smaller and smaller, and then applying initial conditions, events, thermal events, load events, shear events, electric events, and so on and so forth. Definitely not going to read this. But the development of finite element analysis is important here forward. We need the plans, and if we have the plans, we can use FEA to run an infinite amount of simulations to answer this. What's necessary to make a building collapse at free fall speed? Thermal, fire simulation and modeling, as well as structural stress development and or transfer and impulse dynamic frequency response, finite element method analysis modeling needs to be applied thoroughly to WTC 1, 2, and 7 and structures to understand what is possible and what isn't. There were stresses, and there are stresses inside that building all the time. They're called gravity. The building was designed to withstand gravity, and our development of stress theory has occurred over a couple hundred years. The basic, simple answer to stress is its force over an area. Now, we have particular stresses that give us indication. Rigid body mechanics is one study, and it's your introductory study of engineering, but solid body mechanics is a more difficult study. So we have to look closer at stresses and their tensors. And the man that helped us get there real quick, his name was Richard von Mises, brother of the economist. Arthur von Mises' father had two very smart kids. He should be proud. Most of the stresses that we are concerned with the deformation of materials, are the von Mises stresses. And that's typically the output of FEA, is von Mises stresses. There he is. We have this man to thank for the results of a lot of our FEA finite element analysis work. We want to know how materials deform and can an office fire radiate enough heat through the fireproofing on steel beams to cause the steel beam to expand enough and therefore break away. How much von Mises stresses will occur at the clip connections between a beam and a column? Is there enough from office fire to make this occurrence? This is the man who developed much of this over 100 years ago, and this is what we have today. And notice the outputs of these analysis, dynamic FEA, von Mises strain, von Mises stresses. Von Mises predicted with tremendous accuracy. Now our FEA software proves him right. Just like modern economic theory may prove Ludwig von Mises to be right in all matters of economics. We can use this in many different applications, medical, showing how a cell phone and its delicate internal parts will hold up over shock studies, drop studies, and so on and so forth. Will it take a 10-foot drop? Will it take a 100-foot drop? Can we drop it from the top of a tall building, and will that phone be okay? Well, we can find all of that out without dropping an actual phone. We can do it in software now. That's good. So we can also take that building, recreate that building in CAD if we can get the plans and specifications and do an infinite amount of finite element analysis simulations. Let's drop a magic amount of weight, 1,000,000 pounds on the building, 1,000 pounds on the building, 100 million pounds on the building, and see what happens. Let's take some columns out, do the same thing, see what happens. Let's put some fires inside the building, create heat sources, take some columns out, see what happens. Ultimately, we can get to the bottom of what it will take to make a building fall at free fall speed. This is quickly how the process is done. You take a solid, you create it in CAD software, you throw a mesh on it. You can throw a finer mesh on it with more nodes. The more nodes, the more computer power you will need. You can set initial surface conditions. I'm going to fix it here. I'm going to pin it here. I'm going to hinge it here, whatever. And you can put loads on it. You can put heat sources near it. You can do an infinite amount of things to recreate real-world events. And then you can get the results. I see. The highest stress point is right here, right here. Maybe with 10,000 pounds, I need to put a stiffener plate right here. Maybe I don't need all this material here. Whatever. You can make all these design considerations with software, but we need the plans. We need the construction plans to accurately represent the building. Otherwise, we'll get the criticism of, well, without the plans, you don't know. So then we have to make assumptions, which weakens our argument. Now, this is just a crude little sketch I drew of the magic column 79 that broke free. And I just want to illustrate the point. We have to look at the clip connections, the clip tables, the bolted connections, so on and so forth. Without that, we can guess. And we can still recreate this building, and we can still run simulations. Let me show you the government's NIST simulation. Here it goes. And they're saying, Dr. Kirkpatrick told me that a lot of internal damage happened inside first. And then does that match what really happened? It's gone, man. Sorry about the expletive. Look at it again. Did that match the computer simulation? This is the finite element analysis. Now, I showed you slides of what a finite element analysis looks like. And does it match? No, it doesn't match. These floor beams right here going across are all attached to these other floor beams. And they're all attached to this column. And they're attached to the concrete. They're attached to the rebar. They're attached, they're attached, they're attached. And we got this report saying they suddenly became free. Well, how does that happen? Can that happen? Okay, here's some construction plans, and this is what I want. Because I want others and myself to recreate this building in computer software and run simulations. These are what plans and specs are. Now, the plans and specs that came out from WTC 1 and 2 that I argued with Jason Burmis, a guy I respect and like, he said, oh yeah, the plans are out. No, they're not. Plans and specs will have a signature and a stamp by an architect and an engineer, and they'll have a date, and they'll have a signature. We don't have that. We don't have that for Building 7, and we need that. We don't have that for Building 1 and WTC 1 and 2, and we need those. We need the construction materials testing reports. We need the submittals. We need the RFIs, requests for information. We need the welding inspection reports. We need all that stuff. We need the material